Hey, mathletes. Here we are in our last lesson in radicals called solving equations. Make sure you've got your graphing calculators with you because we're going to use them to help us out. So what we're going to do is we've got equations. So again, an equation just simply means we've got an equal sign. The last couple of lessons, we were just simplifying expressions. So we're going to solve these things, and we're going to do it graphically and algebraically. So let's grab our graphing calculators, and what we're going to do is this. We're going to graph whatever's on the left-hand side in y1 and whatever's on the right-hand side in y2. So hit pause on the video and put those in your calculator. I'm going to do the same, and I will see you in just a second. Okay, you've taken the time to put that in your calculator, and let's pull that up so we can see what that looks like. So you should put it in y1 and y2, just like that. And now just make sure your window settings are back to normal. So I'm just going to go zoom standard 6. And there it is. Okay, there's my two graphs. Now the blue one is what the graph of a radical looks like. So where is our solution? Well, our solution is where these two lines intersect. So the first thing I'm going to try right off the bat is to go second, calculate, intersect. First curve, second curve, guess, who cares, enter. And I get this error says no sign change. Okay, I'm going to hit 2 for go to. All that means is the calculator can't see it. It's not within the X domain there. So I'm just going to go to my window settings and I'm just going to make X max bigger. I'm just going to jump to maybe 20. Hit graph. Now the calculator can see the point of intersection. Now it will calculate that for us. First curve, second curve, guess, who cares, enter. And there it is. Your answer is 11. So we're only looking at the x value because we only had an equation of one variable. First thing I always want you to do is to graph and get the answer. Might as well. We know the answer is 11. Now let's prove or show that the answer is actually 11. So here's what we're going to do. These actually aren't that bad. What I got to say to myself is I've got to get rid of that radical. It's in the way. So how am I going to get rid of a radical? Well, the inverse of square rooting is squaring, right? Squaring and square rooting undo each other. So what I'll do first here is I'm going to say I got to get this radical by itself. And it's negative, so I think I'm going to make it positive. So I'm going to subtract over the 6, and I'm going to add the 2, square root of 2x plus 3 to the other side. Okay, again, there's more than one way to do this. But now I definitely want that radical isolated like that. So now what I'm going to do is I'm going to square both sides, right? Square both sides. And again, the reason I want to do that is the inverse of square rooting is squaring. Look at what happens on the right-hand side. Just 2x plus 3. On the left-hand side, that's x minus 6 times x minus 6. So that's x squared minus 12x plus 36. And now we're looking like something we had just in quadratics, didn't we? So let's bring everything to the left-hand side, subtract the 3, and make sure you've got that equals 0 there. And now this is something that we can factor. So we're going to say, okay, look at that's x minus 11, and that's x minus 3. And so therefore, we have x is equal to 11, and x is equal to 3. Okay, but oh, wait a minute. Let's go back to our graph for a second. Let's go back to our graph. Okay, these two things aren't crossing at 3. What the heck is going on at 3? At x is 3, they're not even close to crossing. So the thing you want to do here on all of these questions is you want to verify your answer. So to verify my answer, I'm going to sub it back into the original equation. So I'm going to verify, let's just go to black maybe. And so I'm going to verify this. And I'm just going to do it over here. I'm going to run out of room here, okay? I apologize. So I'm going to verify this. So I'm going to sub in first, x is equal to 11. So remember, we do left-hand side and right-hand side separately. We're trying to show they're the same. So I sub in 11. 11 minus square root of 2 times 11 plus 3. That's 11 minus the square root of 25, which is 11 minus 5, which is 6. Well, what's the right-hand side? The right-hand side is just 6. So I've verified it. It's fine. That's good. That's one answer. I know 3 is not an answer because I graphed it. But what if I hadn't graphed it? Okay, what if I hadn't graphed it? Well, let's just go and see what happens. So if we subbed in a 3, like that, and then we're going to get 3 minus, well, what are we going to get here? We're going to get 6 plus 3, which is 9. And the square root of 9 is 3. And 3 minus 3 is 0. Is 0 equal to 6? No, 0 is not equal to 6. So what you're going to tell me, this is really important. You're going to cross this off, and you are going to say, this is called an extraneous root. It's called an extraneous root, meaning it's something that we get when we're doing our work, but it's actually not going to be a solution. So I need you to do both. Okay, so that's why you want to graph right off the bat. It tells you what is your answer or answers and how many answers we have. Okay, I'm going to hit pause and I'm going to do some erasing. While I do that, I want you to graph the second one. So y1, y2. I'll see you in a moment. Okay, so I've graphed this in y1 and y2. Let's hit graph, see what happens. And there it is. Okay, so I can see my point of intersection is going to be right here. So second calc, intersect. And first curve, second curve, guess, who cares? There's my answer. It's right there at 4. So we know our answer right off the bat. That's good news. Now let's go and solve this thing algebraically, right? Let's go solve this thing algebraically. So we know our answer is 4. Did I say 4? I said 4. Okay, so let's solve this thing. So this one's a little bit more difficult because this time we have 2 radicals. So what I'm going to do when I have 2 radicals like this is I'm going to move one radical to the other side. Doesn't matter really which one, but to keep it simple, I'm going to move the monomial one over. It's a little bit easier. Okay, why did I do that? Well, I need to get rid of these square roots. And again, the inverse of square rooting is squaring. So I'm going to square both sides like that. Look at what happens. Well, on the left-hand side is easy. It's just then x plus 5. But on the right-hand side, this is going to be a little bit of a mess. We're going to have to do this, right? This binomial distribution. So this one's going to be a little bit trickier. So here we go. 5 multiplied by 5, 25. Minus 5 root x. Minus 5 root x. And a negative times a negative is a positive. And root x times root x is just x. So I'm going to simplify. Well, what have we got? On the right-hand side, we can simplify these two to give us negative 10 root x plus x. And you're saying to yourself, oh, I've still got this radical in here. I still got this x, root x. Okay, well, let's start solving for this root x. So I'm going to leave that root x where it is. Let's subtract 25 and let's subtract x. Well, look what happens when we subtract x. X minus x is 0. Let's subtract 25. I get negative 20 equals negative 10 root x. I'm trying to solve for x, so let's get everything away from x that we can. Let's isolate for x. So let's divide both sides by negative 10. That's 2. Now I'm going to square both sides. And what do I end up with? I end up with x is equal to 4. Exactly like we said we would. Okay, again, I would verify that algebraically, but we kind of already verified graphically. So there it is. So friends, when we've got 2 radicals, what you're going to want to do is you're going to want to move one radical to one side and one radical to the other. And then you might have to repeat the process like we did here, where you might have to square a second time. It happens. Okay, let's try this one more time. root x is equal to -4. Okay, so this one looks easier than the last one. All right, what do? I got to get rid of the radical. Let's square both sides. So that's x minus 2 is equal to 16. And that's x is equal to 18. And I'm done, right? Not even close. Let's verify. So when I verify again, I'm going to sub in x is equal to 18 into the given equation. Left-hand side, right-hand side are separate. So left-hand side, I'm going to get 18 minus 2, which is 16, and root 16 is 4. Sure it is. But on the right-hand side, it says it's equal to -4. Does -4 equal -4? Does +4 equal -4? No way, it does not. So what does this mean? It means this here is an extraneous root. And what it means for us is we don't have an answer. So what you're going to say is simply, we have no solution. Just like that. And if you were writing this in set notation, you would write it like this. It's the empty set. There's nothing there. It's a sad question. There's no answer. Okay, so the key thing is here, friends, you really need to verify your work. If we even just go back and look at this question, I wouldn't even expect you to do any work. What this says is a square root is equal to a negative. Not that I know of. You can't square root a number and get a negative. So you could have told me right off the bat with no work. There was no solution. There it is, friends. There is solving these things algebraically and graphically. Actually, you know what? Let's do one more thing before I shut her down. Let's show you what this one looks like graphically. Might as well, right? Okay, let's go and graph this thing. So let's go to y equals. Let's clear out any garbage we have there. And let's go square root of x minus 2. And the other side was -4. Okay, what would that look like graphically, friends? Well, you see the two lines are never going to intersect. So if they're never going to intersect, no solution. Okay, now I'll shut it down. Hope that helped. See you later.